All right, so our next most important peak is going to be the carbonyl peak. So remember, a carbonyl is a C double bond O, and this occurs right around 1700. And this one is very strong and sharp. Right, so you can see it in our chart over here, 1650 to 1800. And let's go ahead and take a look at some examples of some compounds with it. So here's this vanillin. Again, it's in this very non-polar solvent. So even though it does have an alcohol, it's not a wide peak, but I wouldn't expect you to be able to identify that. It does, however, have carbonyls, right? And so if you're thinking about 1500 is right here, 16 right there, 17 right there. This is the carbonyl peak right there. And so you can see it is indeed quite strong. If we move over to this 2-butanone, we can notice two things, right? This 2-butanone does not have an alcohol, and you can see there's no broad peak over here. It does, however, have a carbonyl, and so you can see the CO stretch right there at 1750, right? Very sharp, very powerful peak there. Next up on our pictures, we have isoamyl acetate. This is actually what gives like banana smells. But again, you can see right around 1700, we have this very sharp, strong peak right there. And to just compare it to something that doesn't have this peak, right, we have ethanol right here. It has this big OH stretch. And then you'll notice there's no very strong peak right there because it does not have a carbonyl. And then finally, we have this compound right here, ethanoic acid, which is a carboxylic acid. And so when you have carboxylic acids, you see you have an alcohol as well as a carbonyl. And because of the hydrogen bonding these things can experience, we're going to broaden out both peaks, right? So you see your alcohol peak here is very broad. And then your carbonyl peak is also quite broad. So if you see a broad carbonyl peak, that means that you have a carboxylic acid. You can actually pull a lot more information from this carbonyl peak. If we go over to this UCLA chart, you can tell that not only can you tell it's a carbonyl, but you can actually determine which type of carbonyl it is, right? Aldehyde, ketone, ester, carboxylic acid, or amide. And you can tell the different regions there, right? And then the note there is one of the strongest groups, and then you can determine which carbonyl it is. That's not something I'd expect you to be able to pull from without the reference table, right? If I give you an exact number and give you the reference table, then yes, you should be able to identify it. But for all I really expect is if you see a really sharp peak here, no, that's a carbonyl.